All right. Hey guys, welcome to this week's lesson. What we're going to do today is implement our collision detection in our ship shooter game. So this is going to be really cool, and it's going to really work out loops and specifically nested loops. So we're going to kind of demystify how we can take this idea of our laser and detect when a given laser hits a given enemy. So let me just recap real quick where we're at. And we're going to go ahead and clean up this code a little bit too. I'm going to comment some stuff out and maybe, segment it out a little bit more. So we have our code here. And, oh, actually, let me get my scene up here. There we go. Now you can see my code. So we have our code here. And let's just run down the top level structure of this program, right? We're putting everything in one file. We have kind of a couple of different core components to this, right? If we start at the top here, I'm going to add some comments here. So these are our global variables, and we only have two global variables here. And I'm going to segment them like this so they're kind of visually appealing here to see. So I'm just going to go ahead and do this and make it all kind of separated like that. Those are our global variables. We have two. We have the ship and we have our enemies. Now, what are the differences between these two? What do you guys think? There's a huge difference between these two, right? One of them right now is just an empty variable, and one of them is an empty what? Array, right? This is the enemy's array. So this is an empty list, and this is just a single empty bucket, right? It's like one entry in an array. It's just a single variable. Now, below this is where we have our class definition. So these are our blueprints for the different pieces of our game. So as we've defined, there are three core pieces. We have our enemy, we have our ship, and we have our laser. Now, this design came out of us just exploring the idea of this specific game, right? What we're trying to actually accomplish. So really focusing more on the English part of this, right? What are we actually trying to solve, and then translating that into code and specifically into these classes or blueprints that describe the different pieces of our game. So the different pieces we have are our enemy. So this is our enemy class, and I'm going to say it's our enemy. I'll call it blueprint here, right? Class. Then we have our ship class, and then we have our laser class. Awesome. So those are our different class definitions. Let's go ahead and just put a little separator in there. I typically don't do separators like this. I don't know why I'm doing them like this time, but kind of like it. Kind of flows nicely. A lot of times I'll do something like this. You still need to do the double slashes, but then do stars. But the slashes, I think, work. So, all right, so we'll go ahead and separate that. And then down here, we have two functions, right? These are our core P5.js functions, which are, setup and draw. And if we look in our setup, you can see that, we do our typical create canvas. We create our ship. So this is where we fill in that bucket, that ship variable that we've defined up top. We fill it in with our new ship. So this is a new instance of this blueprint. So we just stamped out that ship blueprint into this variable. And then we create a new enemy here, which we actually don't need to do. I'm going to take this out because I think this is when we were testing an enemy. So we have this one kind of floating enemy that's not part of the enemy array. I'm going to take that out because I don't think we're using it anywhere. So our setup function is essentially two lines of code, right? It's just create canvas and our new ship. Awesome. So now if we look at our draw function, there's a little bit more happening in our draw function, right? I'm going to move this over just a little bit here so we can see. Our draw function, does our typical background painting. So we're painting the background a grayish color every frame. Then we're calling our ship move and ship draw function in every single frame. So this enables us to be able to detect user input and things like that inside of these methods, right? These are methods on our ship instance. Now here what we're doing is every 10 frames we're using a conditional statement, and we're saying, hey, if the frame count, which is a built-in global in P5.js, is divisible by 100, then we're going to do this magical line of code here. We're going to go ahead and push a new entry onto the enemies array, and what we're going to push onto that is going to be a brand new enemy. And that brand new enemy is going to have a random position in its width, and it's going to start its life in the -100 space, which will be somewhere up here, right? Awesome. So now we have a method for being able to spawn enemies by just using this simple little conditional statement. And now what we want to do is we want to actually make the enemies move and draw to the screen. So to do that, we need to loop over every single one. And this is where we're using loops, right? So we've got all these different ideas we're implementing here. We've got classes, we've got conditional statements, we're calling methods on them, we've got global variables. Now we have some loops, and we're going to go ahead and loop over every single enemy. So starting at 0, we're going to loop until I, or our looping variable, it'll loop as long as I is less than the length of the enemies, and it'll increment 1 per loop, right? So 1, 2, 3, right? Or 0, 1, 2, 3. And then for each loop we go through, we're going to go ahead and index each enemy. So this is essentially like us going through a list and saying, I'm going to start with the first thing on the list. In the case of an array, it's the 0th thing on the list, right? We're going to start at 0, then we're going to go to 1, then we're going to go to 2, then we're going to go to 3. And for each one of those, we're going to call the move and draw method on this enemy. And this is what creates this idea of enemies moving, right? If we started at, say, for example, 1 here, let's see what happens. Actually, we're not going to see anything. Let's start like let's start our enemies a little bit higher in the list here. You'll see them spawn. You know what? It's not doing what I expected it to do. I wanted 1 to just stay static on the screen, but I guess it's not going to do that here for whatever reason. I won't dwell on that. But the point here is that we are looping over every single enemy, right? So every enemy is getting touched, and we are calling the move and draw method on each one of those. Remember, these classes are just blueprints, and we can stamp out as many of these as possible. Super powerful concept, right? So in the case of our enemies, we have many enemies, right? We only have 1 ship, but we have many enemies. And that takes us to the third piece, which we did this week, which is our lasers. So the lasers, as you can see here in our setup and draw, we know nothing about lasers, right? But we do have our laser class here, which defines our move and draw and what a laser actually is. But lasers don't live in the kind of the global context of our program. They live on our ship. So we're thinking like, if we're building an actual ship and we want to bolt a laser onto that ship, the laser is part of the ship. So just like we did with the enemy array, we're going to create an array, but it's going to be inside of our ship, and we're going to call it laser gun. And that laser gun is chilling right here inside the constructor, and that initializes this empty list. And now we want to be able to, add new lasers when we detect that a laser is, when a user actually hits the space key. Whoop, I'm getting notifications from my, let me turn that off. Okay, so lasers are inside of our ship, and we initialize them in the constructor. And now what we want to do is in the move method, where we do all of our key detection work, we can go ahead and now detect whether a space bar is hit. And if it is, we created this new fire method that is part of the ship that is going to go ahead and create a new laser. So if we look at this fire method, super simple, but it does the same exact thing that we did with the enemies. We're pushing a new instance of a laser onto the laser gun array. Awesome. So when we hit space, that's all that's happening is we're putting a new laser on top of that list. It doesn't actually do anything visually. We now need to write that piece, right? So here, inside of our move method, which we can debate whether or not this is the right spot for it, but we put in this for loop, just like we did with our enemies, that enables us to loop over every single laser inside of our laser gun and then move and draw them. Okay, awesome. So that's kind of the super quick overview of where we're at in this game, going over the architecture of it and how everything is kind of fit together. Now, what we want to do today is we want to be able to detect when a laser hits an enemy. So this is super interesting because we do need to implement kind of a crude way to do collision detection. Now let's think about this for a second. Let me take a sip of my tea for a minute. Ooh, that's hot. So we want to be able to detect if any laser hits any enemy. So if we need to actually go through each one of these lasers and each one of these enemies, what is the tool that we need to use? We've already used this tool twice already. If we need to go through multiple things and we want to automate that, we're going to use a loop, right? We're going to go ahead and loop through them. But the difference here is that for every laser, we want to check every enemy. So we want to go through, it's basically having two lists, right? We have our enemies list and we have our lasers list. Now what I'm going to do is I'm going to go ahead and say, all right, for this laser, check every single enemy, right? And then I'm going to go to the next laser. For this laser, check every single enemy, right? So this is perfect for a specific type of configuration of a tool that we've encountered already, right? This is this idea of nested loops, right? Whenever we want to take a list, and for every item on that list, we want to check every item on another list. A nested loop is a good tool for that. There are many different techniques out there for doing this crazy efficiently, depending on what you're trying to do. And this really touches on the idea of algorithms and how we can develop and study different algorithms for different kind of efficient ways to do things. Now, in a deeper computer science context, we would study things like big O notation and how space efficient certain algorithms are. This is more of kind of a brute force technique. It's not extremely efficient, but it works really well for what we're trying to do. So how do we do this? So what we're going to do is we're going to go ahead and loop over every single laser. And then we're going to loop over every single enemy. Now, where are we going to do this? Now, we could do this in a bunch of different ways. It probably makes sense for us to do this inside of our draw method, right? So we'll go down, we're inside of our draw function, and the draw function all the way at the bottom, after we looped over all these enemies, we're actually already looping over all these enemies, which is good. So we may want to think about this a little bit differently here. We could loop over all of the lasers and then check all the enemies, but because we're already looping over all the enemies, maybe we'll do the inverse and we'll check every laser for every enemy. That might work. All right, so let's see what we could do here. So if we do that, let's see. Right below this, right? So here we're already checking every single enemy. Now inside of this for loop, now make sure that you're inside of this for loop, right? This bad boy right here that is looping over every enemy. So right before the closing bracket right here, this is where we're going to put another loop. So now we want to check each laser. All right, so every single enemy, now we're going to go through and we're going to say for let j, we're going to use a different looping variable equals 0, as long as J is less than, what are we going to check here, right? We need to get the ship's laser gun. So we could say ship dot laser gun dot length, right? Because we can access this property, which is the laser gun array. And then we'll go ahead and increment by 1. Now you want to open and close those curlies and get yourself right in the middle of that next loop, right? So you can see here we have this nested loop now. We have this for loop here that goes over every enemy, and now we have a for loop inside a for loop. It's like Inception, right? And this loop is now going to check every single laser inside of the ship. Now, what do we need to do here to figure this out? Let me go ahead and get into Figma, because I'll do a little sketch here. Okay, so let's go ahead and conceptualize this a little bit, right? So we're doing this loop, and we're able to go ahead and check every single enemy, and for every enemy, we're checking every single laser, right? Now, what do we actually need to do here? We need to test whether or not a laser is on top of or in the range of a given enemy, right? Now, we did something similar in our DVD logo project, but it was kind of the inverse, right? In the DVD logo project, we tested out the dimensions of the screen. So we were really checking out, hey, whether or not we hit the edges of the screen, right? So we have our X, right? And we have our Y, which tell us exactly the position of something on the screen, right? So there's X and Y. Is our X. Make that a little bit bigger so we can actually see it. And then we have our Y, right? Now, each one of these pieces, say for example, an enemy, has an X and Y, but that X and Y is defined here, right at the top corner right here. So the X and Y of a given enemy is defined right here. So if we have a laser, which is a line, right? Our laser looks like this, and let's make that bad boy red so we can make it a laser and maybe a little bit wider, right? So our laser looks like this. Now our laser has an X and Y that is sitting right at the top, right? So we have this laser right here, and the X and Y is right at the top here, and this is our laser, right? So awesome. So now if we're moving this laser around, and we've got this laser going through the screen, and pew, pew, it's coming at the enemy, if I get here, is it going to register as a hit? Right? We need to measure the distance between this point and this point, right? So the measurement that we need to make is the distance between these 2 points, right? So we need to figure out what this is, right? And this is actually a classic problem in geometry where you take the distance between 2 points, and you basically just subtract, right, the 2x points, right? So if this is, for example, if this is, say, we'll make it simple, right? If this is 0, comma 0, and then this is, say, let's make it something, really, we can make it anything at this point. We can make it 10, comma 10, right? What's the distance between these two? We would take the difference between 0 and 10 and 0 and 10, and the distance is 10, right? It's just simply 10. It could get a little more complex as you change these numbers, but the bottom line is that the equation of this is the d equals x1 minus x2 plus y1 minus y2. All right, just a little math. Not gonna go crazy into that. And you know what? I'm gonna probably check that real quick. So if we have these two different points, 0, 0, and 10, 10, we need to find this distance. Now, how do we do that? Now, this is actually a classic problem in trigonometry, and we can use what's called the Pythagorean theorem. Right? So the Pythagorean theorem is basically this little formula where c is the distance and c equals the square root of a squared plus b squared. Now, I'm not going to get too crazy into the math because this is not a mathematics course, but the bottom line is that we would take the difference between the 2 points, x1 and x2, and y1 and y2, and we would plug it into the Pythagorean theorem here, and we would get our distance. Now, luckily for us, we don't really need to worry too much about the Pythagorean theorem, right? We have a built-in distance function inside of P5JS. So if I go here and I go to our reference and I search for dist, we have this little function here. This calculates the distance between 2 points. Awesome. That's exactly what we need. So we don't need to worry about implementing the Pythagorean theorem, which we could do. It's pretty simple to implement a formula like this, right, with JavaScript. But let's go ahead and use the tool that already exists. Why reinvent the wheel? So let's go ahead and take a look at the reference here. And you can see that we can take 2 different points, and we just have to plug in x1, y1, x2, and y2, and we will get a single value which represents the distance between those 2 points. Awesome. So let's go back to our code here, and let's go ahead and now calculate this distance. Now we're going to create a new distance variable here, and we could just say var distance equals, and we could define this variable maybe outside of this loop, but we'll do it here for now. Now we're going to use this dist function, and we're going to give it the first point here, which would be our enemies point, right? So we're going to say enemies. Now pay attention to exactly what I'm writing here, right? Because it matters which looping variable we use. I'm going to say enemies sub I, right? Because the outer loop is I, and the outer loop is what's looping on the enemies. Enemies sub I dot. Now we need to access its x position, right? So we're going to say dot x, and then enemies sub I dot y. Then we're going to give it the second point. Now the second point is going to be the laser gun that we're doing here. So we'll go ahead and say ship dot laser gun sub. Are we going to use sub I here, or are we going to use the looping variable that we're using for the laser gun? So in this case, we use j, right? Oops, sub j dot x, and then we'll do the same exact thing here for laser gun sub j dot y. Now this should get us the distance for each one of these, for each laser and for each enemy. Awesome. So let's go ahead and do this. Let's go ahead and console.log this and see if we're getting any values. So I'm going to go console.log distance, and let's hit play here. And all right, we're getting values. We are getting values. And as these lasers go away, these values should get, well, they're gonna range because we're spawning new enemies at the top. And you may notice the performance of this is horrible as we do these console.logs. If I take this console.log out and hit play, it should be okay for the time being. But we will wanna do some cleanup with this, because we have a lot of objects that we're keeping around that we don't need to keep around. But for now, we want to get this distance function working. So awesome. So that looks like it's working. Now, because of let's go back to our sketch here. Now, because we're comparing these two, right? This distance here, we don't want this distance to be 0, right? Because if it's 0, we're assuming this. We're assuming that we're getting right here. So the hitbox would be this. if a user sends a laser here, it wouldn't hit. If they sent it here, it wouldn't hit. So what we want to do is we want to provide a little bit of an offset. And that offset should be equal to what? The offset should probably be equal to the width and the height of the enemy, right? So this width and height, if it whatever it is, I think it's 20 in our program, we should probably check to see if this distance is 20 or less than 20, right? 20 or below. So let's go back to our code here. Now we need to test this value. So what tool in our toolbox do we have to test values in our system? It's not our loop, right? We have a variable that is storing this distance. We now need to use what? A conditional statement, right? So we got to go ahead inside this loop now. We're going to say, hey, if the distance is less than 20, then what are we going to do? Now, we actually don't have anything to do here yet because we want to be able to, I'll say, destroy the enemy. But we have no concept of an enemy being destroyed yet. So we have to extend our enemy class to be able to support the idea of being destroyed. It's not going to just happen. We need to make it happen, right? So we need to get out of our draw function for a second, go back to our enemy class. Now, I'm going to expand our enemy class. Now, I'm going to do this very simply, right? We're going to just introduce this idea of being alive or not, right? So inside the constructor, I'm going to say this dot alive equals true. So when an enemy is born, the enemy is alive by default. We have an alive enemy. Awesome. It's gonna make the enemy alive. Now, what we can do here is we can only draw enemies if they are in fact alive. So let's see. If we say, hey, we need to now test a variable. So what do? We use another conditional. Inside of our draw method, we could say, hey, if this dot alive, then we're going to go ahead and draw it. Now, if it's not alive, this code here will not execute. So we will not see anything. We're still calling this function, but it will not execute. And you know what? Maybe one thing we can do for this, because we'll do something different when we do our cleanup, is let's do this. Let's always draw the rectangle. But we're going to say if alive is blue, and we'll say else fill red. So if it's not alive, it's going to be red, and if it is alive, it's going to be blue. All right, awesome. So now this is good, but now we have to be able to change its aliveness when it gets hit. So we're going to go back down to our draw function, and inside of this conditional, we're going to say, what are we going to say here? We're going to say enemies sub I, because this is the enemy that we're focused on right now, right? This is the enemy we just tested with this distance. Enemy sub I dot alive equals false. Okay, awesome. This should do it, guys. Let's see what happens. So if we go ahead and hit play here, and we start shooting, I'm going to hit this guy. Boom! Boom! Nice. It is working. We have collision detection. Excellent. So I went a little quick there at the end. Definitely maybe rewind that and slow it down a little bit. But this is really the meat of this, is this nested loop, right? We loop over all of our enemies. We loop over all of our lasers. And then we test the distance between the given enemy and the given laser that we're focused on. And we check to see if the distance is less than a certain value. And if it is, we simply flip a property inside of the given enemy that we detected we hit. And then we use that property inside of our laser, or our enemy, I should say. And we say, hey, if it's a certain value, make the enemy a different color. Now, this is where we can kick off things like animations and things like that. Maybe we want to have an explosion or something like that. We could certainly do that here. And now indirectly, what you just did was you used the Pythagorean theorem to be able to actually calculate the distance. Now, you probably learned the Pythagorean theorem in grammar school, but you never actually used it to do something real. And this is what we just did. So hopefully that's interesting to you. So play along with me, get this working. We will review this on Monday together in class, and yeah, have fun. I'll see you Monday.